everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 7i. Myself Anshika Jain, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategy ICTCS 2025 Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15th in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for the questions and answer. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session, Dr. Archana Preetam Kale. Ma'am is an assistant professor at MEC Wadia College of Engineering, Pune, India. Her academic and research interests include emerging technologies in engineering education with a focus on innovative teaching methodologies and applied computer engineering domain. Welcome to the session, ma'am. Would you like to share a quick opening remark with us?
Yes, thank you. Thank you for inviting me as a session chair as well. We will start now, ma'am.
Okay.
Yes.
So now we'll start with the papers. First, we have Arvindida to present the paper title A Survey on Handwriting Image in Dyslexia Research and Education System Using Artificial Intelligence Technology. Arvind, are you there? Arvind, are you there? Okay. So we'll be moving ahead. Next, we have Rekha to present the paper title Deep Learning Based Data Driven Models, a Hybrid Approach for Time Series Weather Prediction. Rekha, are you there?
Just a minute. Yes, I'm there.
Yeah, you may please start with the presentation.
Shall I share my screen?
Yeah, you can share your screen now.
Yeah.
Yes, we can see your screen. You may start now.
Yes. Yes, good morning all. This is Rekha Kulkarni, who will be presenting along with my co-authors, Ayush Chanekar, Pranjali Joshi, and Mukta Taklikar madam. We belong to Pune Institute of Computer Technology, Pune, and our title for the paper is Deep Learning Based Data Driven Models, a Hybrid Approach for Time Series Weather Prediction. And today we are going to have a brief introduction and the literature review. Then we'll go ahead with our problem statement and the proposed methodology. And we have applied a hybrid approach to the weather forecasting problem with data-driven models. And then we are going to discuss about the results. And we'll end with the conclusion and the future enhancements as a part of our presentation. So to start with, generally weather forecasting, which is becoming very challenging day by day. And here we want to explore our data-driven approaches instead of using the conventional numerical weather predictions. Numerical weather predictions, wherein they basically employ the equations which require high computational demands. So we wanted to explore in what way the data-driven methods will help us in predicting the weather and the climate with the help of the deep learning approaches. So particularly, we have made use of 3 different models in our study, which is related to the CNN LSTM, and along with that, we have also explored the recurrent neural networks and the ResNets as LSTM, ResNets, and the the deep learning models related with CNN, LSTM as a hybrid models. So the next we have as a part of literature survey, this is what we have compared. The data-driven forecasting will generally make use of deep learning has demonstrated the viability of pure. Just a minute, I think. Ignite I think my PPT has been.
Your screen
Ma'am,
is shared. Kindly go on the PPT part.
Yes, actually the PPT itself is not seen to me, I think.
ma'am, is it okay if I present?
Yes, I
Yeah,
think,
that's totally fine. The co-authors
yeah,
can
yeah.
present
Okay, okay.
the
Go
screen.
ahead, Ayush.
Yeah, thank you. Is the screen visible?
Ayush's screen is not visible currently.
Okay,
Yeah,
one
it is
Yes,
second.
visible
it's
now.
visible now. Yes.
Okay. Uh, is the, I mean, slideshow visible right now? I'm not sure. I can't really
Yeah,
check.
yeah, it is. It is.
It's
Okay, okay.
visible.
Thank you.
You,
Yeah.
s-
Yeah,
you
Yeah.
yeah.
start with literature survey.
Yes. Okay.
Yeah.
So, continuing from what ma'am previously stated, the literature review basically informs us that deep learning is a promising approach for data-driven forecasting. And most importantly, deep learning has been benchmarked and it has produced consistent and reproducible results with lesser compute as compared to the numerical weather prediction models. Moving on, like ma'am previously said, we have taken three models in our study this time, and the main sort of problem statement for this was that convolutional neural networks and long short-term memory, that is LSTMs, have shown significant promise in these forecasting tasks to basically capture the both temporal as well as spatial dependencies in weather predictions. So this is what basically led us to use three methodologies. The first one is an LSTM, which is just a baseline LSTM. The second one is a novel hybrid CNN LSTM model, which we are proposing to extract both spatial and temporal features from time series weather. And the third one is the ResNet 50 1D, which we are using basically to compare the results and to benchmark our novel model. Moving on, this is the basic architecture or overview for the LSTM diagram. As you can see, we have three layers over here. In the table, yeah, we can view the specifications for each and every layer, where we have three layers with all with return sequences as true and filter sizes as 256, 128, and 64. The last dense layer is just for the regression output, that is the continuous value of the time series data. These are the optimization techniques we used in the model. We've used learning rate decay so that we don't want our model to overtrain due to a really high learning rate. And we have used Adam optimizer as well as early stopping just to prevent overfitting. This is the architecture for our hybrid model, the one which we have proposed. So over here we have a part which is convolutional layers. The idea for this is that this sort of 1D convolutional network will extract all the spatial dependencies out of the weather data. Now, for the weather data, we have considered the JENA weather data set, in which we are using parameters such as temperature, humidity, precipitation to predict um, temperature basically. We have not taken temperature as an input parameter, but we have taken other basically dependencies which indicate temperature. So this convolutional layer extracts all the spatial dependencies, and LSTM will extract all the temporal dependencies and basically give us our predictions. So this is the summary of all the layers in this hybrid model. We have a CNN feature extraction layer with 1D convolutional layers, max pooling, and then this is flattened and given to our LSTM, where we use the LSTM and dense layers. We've used dropout over here because we observed that there was some level of overfitting, but this sort of normalizes that a little. We have used optimizer as Adam, and our loss function is MSE. Moving on. Yeah, so this was the ResNet 150 1D which we used. This is the architecture for the same. It's quite a big diagram, so I had to like display it like this. But essentially, we have a convolutional block, an identity block, uh, like followed by two identity blocks, and we have a skip connection which traverses from each and every block to the next one. Moving on, yeah.
Sorry to
The
interrupt you, but you have 1 minute to conclude your presentation.
Okay, yeah. These are our performance metrics. We've taken MSE, RMSE, MAE, and R2 square, R2 score basically to predict our models. Then these are the results for our model. So as we can see over here, the LSTM model has performed the best, mainly because we had time to optimize the hyperparameters. The CNN LSTM model is followed by quite closely, and the ResNet 51 lags behind as we were not able to optimize the hyperparameters for the ResNet. But as you can see, the CNN LSTM model which we propose is quite close to LSTM in terms of R2 score. Right, this is just a graphical representation of the same that I mentioned. Yeah, and what we conclude is the same, that deep learning models are quite effective for weather prediction, and the results demonstrated clearly show that LSTM model achieved the highest accuracy, followed closely by the CNN LSTM hybrid, and the ResNet model didn't perform as well because suboptimal hyperparameters, and this warrants further tuning. Yeah, and further enhancements, we want to make use of this time series data, which is quite a good resource we have, considering the ERA 5 datasets and the WeatherBench datasets like we talked about in the literature review, and use these images to basically capture more spatial structures and more weather data for better temporal modeling as well as better accuracy. That's it. Thank you. If you have any questions, please feel free to ask.
Thank you so much for your presentation. Ma'am, do you have any questions? I guess ma'am would be writing in the chat box if she has any questions. We'll wait for 1 minute.
Okay, yes.
I guess no questions then. In
Okay,
case ma'am will have questions, she'll drop in the chat box. You can reply it there.
sure.
Sure.
Okay.
Okay.
Thank you. Thank
So
you
we'll
for
be moving on
this.
to the next presentation now. Next, we have Vallabh to present the paper title Design and Implementation of Dual Stage Compact Converter for Auxiliary Power and Accessory Charging in Electric 2-3 Wheelers. Are you there, Vallabh?
Yes, I'm there.
Yeah.
I'll share my screen.
Yeah, please share your screen.
Okay, I hope my screen is visible and I'm audible
Yeah.
clearly.
Yes, you're audible clearly and your screen is visible. You may start.
Right. Yeah. So, hello all. So I am Vallabh Bhatt. To all the organizers, presenters, authors, come presenters, and the panel members of this meeting, a warm good morning to all of you. I am Vallabh, and I'd be presenting our work on the paper titled Design and Implementation of Dual Stage Compact Converter for Auxiliary Power and Accessory Charging in Electric Two or Three Wheelers. So I would be presenting this work on behalf of my co-authors as well. And we are from the Department of Energy and Power Electronics, Vellore Institute of Technology, Vellore campus. So with this introduction, we'll quickly jump into the index. That is, we would be starting with introduction, objectives, problem statement, literature review, summary of the literature review. Then we'll get into the block diagram, circuit diagram, mathematical modeling, system setup, hardware component selection, simulation output, hardware output, future scope, and finally we'll just wind it up with the conclusion. So with this being said, with or without having the knowledge of electric vehicles today, or without having the knowledge of electrical engineering today, so we can, looking at the current situation, it is very evident to us that electric vehicles are the next big thing. And so to support this statement of mine, there's a data which shows here that is 35 million EVs on the road as of 2024, and majority of them are in the low voltage segment, which I mean electric e-bikes, scooters, rickshaws, etc. Right? So as far as an electric vehicle is concerned, the most important part in an electric vehicles becomes power delivery. So when we talk about power delivery, so there can't be multiple power sources for us for all the auxiliary uh, uh, systems that are present on an electric vehicle. When I say auxiliary systems, it could be lightings, fans, controllers, sensors, multiple n number of those are present on a vehicle. So to power up all of those, we make use of a single channel, which is a typical 24 or a 48 volt power supply. So to generate this 48 power supply is what we are targeting today. And this 24 volt power supply from a standard power supply would be from a standard 12 volt battery to a 24 volt, and then this 24 volt will be powering up an auxiliary systems. So in our case, we are talking about one application, that is USB charging in a two-wheeler, right? So talking about, so this is yet another stat which shows the compound annual growth rate of electric vehicles of about 44% targeted till 2027. So the objective of the work, as I've said, is to take up a standard DC power supply, that is a DC power source, which is a 12 volt battery. In our case, we'd be drawing around 8 volts, 7.3 amps from the source, and then that would make us a DCM based boost converter design. So which the DCM is again a topology which means the discontinuous mode of conduction, where we would be making introducing noises into the inductor, and just by increasing the ripples in the inductor, we would be increasing the output power of the converter. So that is the idea here. The conventional one is CCM, which is the continuous conduction mode, but we are trying to get into the discontinuous mode of operation just to enhance our power capabilities, right? So that is the idea. The problem statement again defines the same thing, because whenever we say a standard for 24 volt supply, there are multiple works. As far as the literature review was concerned, I've displayed it later, but there is nothing that streamlines everything into a single paper. That's why we are targeting to, that's why our idea was to make all in a single paper and get it in a single uh, place, right? So the literature, this is a literature review. So we have segmented around 10 papers here. So, and we have categorized them based on the paper title, techniques used, summary of abstract and conclusion, technology used, that is including, which includes the hardware prototypes as well. So I won't be getting into this as such. I'll just move on to, because this is just theoretical, we can just read it up. But instead, I'll just get into the summary of literature review. That is what conclusion we could draw from it. The conclusion was very clear that there is a need of auxiliary power supply, because in the current generation, in the current days to come, and in the next generation of electric vehicles, we will go on adding more and more auxiliary systems. But to power up those auxiliary systems, the requirement of a particular auxiliary source is a question mark, and which exists even today. But conventionally, it is, as I've said, is continuous conduction mode of operation. But we are trying up a different method, that is discontinuous mode of operation. So this is a simple block diagram of the work that we have done so far. So our work simply relies, if you can see my cursor here, I'll just take a laser pointer. So this is the current work that is done so far. So we have a 12-volt supply, as I've said, which typically comes from a battery. We would be drawing around 8 volts, 7 amps from this, and this is a post regulator which we're using here, and this is a discontinuous switch, and this would be supplied to a DC link cap and then to an auxiliary power module. So this auxiliary power module is what we have designed, and also this 12-volt 60-watt mobile charging block. So this is one of the applications, and here as the diagram continues, there could be n number of applications which from where you can draw the same amount of power. So it could go to an electric drive or a sensor or a controller or any MCP that is present on an electric vehicle, right? So this is a generic block diagram, and now here is a specific block diagram where which explains the number in a little more detail. 12-volt battery, boost converter, and then there's a DC-DC isolated converter stage here, and then that goes to our auxiliary isolated stage, and that goes to our mobile charging block. So the gate pulses here are generated externally through a STM32 microcontroller. So as far as the detailed circuit diagram is concerned, in the same block diagram, I've tried to fit in the circuits as well. So this is the converter, which takes 8 volts here and makes it 24 here. And from 24 here, which is a 60-watt auxiliary rail, we'll drawing up that 24 volts to charge up my mobile charging block here. So this operates at around 2 kilohertz of resonant frequency, not resonant, 2 kilohertz of frequency, and then this operates at around 200 kilohertz of frequency. So this is a zoomed in circuit diagram. So we have a power supply here, and the auxiliary rail is charged here, and the same auxiliary rail is extracted here, and then that goes to our full bridge inverter, followed by series compensation topology, where I have a capacitor and a resistor and a coupled inductor to maintain the isolation. And then this goes to a full bridge rectifier, and then my output cap, and then to my load. So the mathematical modeling remains very generic and simple. So there are a couple of standard wave equations that come with which come from the continuous conduction mode, which is very conventional, right? Where we define output voltage as a function of input voltage divided by my duty, and then I define my ripple in the inductor, which as a function of my input voltage, inductor value, the duty, and the time. And the output current is a function of my duty and my inductor current, and the output ripple is a function of my output voltage and inductor current. So using which I arrive at my output equation for my DCM based inverter. This is a derived function, so which is what we have used in getting the values of those L and C's. So this is again the standard input functions that we have given, which is 2 kilohertz of operating frequency with 50% duty cycle for the stage 1 of converter. The stage 2, as I've already said, operates at 200 kilohertz. So this is the external gate driver circuit. Because we have come up with the hardware model as well, we had to bring up this as well. So this, as I've said, we generate the gate pulses from an STM32 Nucleo board, which operates at roughly 4 megahertz, but we have slashed it up to around 2 kilohertz, and we get the gate pulses here. This is a HCPL 3120 opto isolator circuit, which is used to isolate my primary and the secondary, just to make sure there's clear isolation between my
Sorry to
pulse.
interrupt you, but you have 1 minute to conclude your presentation.
Yeah, sure. I'll conclude it. Right. So this is the gate driver circuit where we would be generating 14 volts of pulses. These are the hardware components. The components selected and the specifications are mentioned here. So this is my simulation waveform where we could see around 11 volts and 5 amps of current that goes to my mobile charging block, which is a simulation output. And as far as the hardware output is concerned, setup is concerned, this is my hardware where I have a boost converter, FET with snubber and heatsink attached, my gate driver, my STM32 external controller, and the power source, which is powering up my, this is the boost converter actually, the first stage of converter. And these are my hardware waveforms where we could see the ripple in the inductor current and the ringing in the inductor voltage, right? So inductor current continuously hitting zero, signifies my DCM being achieved. And then my switch waveforms, my voltage and the current. And then I have my diode waveforms as well. So as part of a future scope, what I want to say here is that currently we have done it only, the hardware implementation is done only for stage 1. The stage 2 hardware implementation remains pending. And just because of lack of time and resources, but that again could be enhancement part. And then the second thing is about adding up the auxiliary sources in parallel with the current model, just to enhance its efficiency. And EMI is also something that has to be taken care. As a conclusion note to it, so as I've already said, there's no specific 60 watt unit that defines hardware and a simulation output clearly. So that has been the motto till day one till now. And I hope with this work we have done it, and these have my references so far, and I've attached them here. So thank you, and this is all from my side. If there are any questions, I can take up.
Thank you so much for your presentation. Ma'am, do you have any questions? Yeah, ma'am has written a question.
Uh, uh, what is the real time? That is the question. What is the real time application? The real time applications of these are in the electric vehicles. For example, if we have multiple battery sources, for example, in case of in place of having two or three dragging the same battery or loading the same battery for different applications. For example, there could be headlights, there could be lighting lamps, there could be fog lamps, or there could be many other sensors around. If you say a standard electric vehicle, you have around 214 to 250 ECUs in a standard fully electric vehicle. So the power consumption or power utilizations become very crucial. So this power stage, whatever I'm telling, is can be utilized there and can replace the current topology where the load is on the battery and the battery life cycle is reduced, right? The use of supercapacitors, which is again emerging technology, is one other alternative, and this can also be yet another alternative. So yes, that is
Okay, thank you so much for your
what.
presentation. Next, we have Deepak Ganwani to present the paper title Empowering Web Accessibility with LLM Powered Code Improvement Tool. Are you there, Deepak?
Yes. Am I audible?
Yeah, you are audible. You may please start with the presentation.
Sure. I'll share my entire screen. I think I don't have the permission on my system to share screen. I'll just have to quit Zoom and join. Can I join in 1 minute?
Okay, okay, you can join in
Sure.
1 minute.
Sure. Thank you.
We'll just wait for 1 minute.
I'll try to present my screen now.
Please do.
Uh,
Yeah, we can see your screen. You may please start with the presentation.
sure. Hi, everyone. A very good morning. So my paper title is Empowering Web Accessibility with LLM Powered Code Improvement Tool. So I'm the presenter. My name is Deepak Ganwani. My teammates were Hardik Akshay and a professor from my college, Sunil Ghane. So starting with some facts on why we chose this problem statement. According to the WebAIM Million 2023 report, among 1 million home pages analyzed, a total of 49 million distinct accessibility errors were detected, averaging 50 errors per page. So basically, when we open any website, there were so many errors that a normal human might not even realize that some specially abled person would face difficulty in accessing the web page would face. The 2023 Digital Accessibility Index report by Audio Eye reveals that digital experiences are inadequate for 1.3 billion people with disabilities worldwide. That makes up for 20% of the global population. So it is quite necessary that when we are designing websites or anything, web view pages in particular, they are designed keeping every user in mind. In fact, web accessibility statistics provided by McKinsey reveal that consumer companies lose 7 billion annually because of inaccessible websites as consumers with disabilities opt for competitors. Not just that, companies are also liable to lawsuits if their websites are not accessible by specially abled people. That is one major reason why we chose the problem statement of providing a code improvement tool that would essentially help them build up all those gaps. So, introduction. Web accessibility refers to the necessity for websites to use tools and technologies designed to help people with disabilities perceive, understand, contribute, navigate, and interact with the site better. So, just for example, let's assume that I am a colorblind person, and if I have used certain XYZ colors on my web page, I won't be able to see it if those are not in the right aspect. Or just for example, if you can consider me as an handicapped person, I should also be able to navigate my web page without even using the keyboard. So yes, there are technologies that can help person with impairments overcome hurdles to digital access, allowing everyone to use the internet equally. In fact, when the internet was first made, the person who created it said it that internet would be an equal place for everyone. So websites are given three ratings: level A, level AA, and level AAA. This is by the WCAG, who have set the guidelines for web accessibility. They give these ratings to websites, AAA being the highest. It is quite necessary for most of the big company giants to have the AAA rating, or they are liable for lawsuits. AAA rating indicates that their website particularly is accessible by almost everyone. Uh, so yes, we clarified a problem statement that we want to meet the WCAG standards, that is Web Content Accessibility Guidelines. Uh, Current web development practices often prioritize rapid delivery, advanced client-side frameworks, and complex solution, inadverting neglecting accessibility considerations. So even I am a developer myself, and when I start developing a product, uh, it would quite often be the case where I'm not being considerate that how some person with special abilities would be able to access it. So it is quite necessary that we found this gap basically, and we wanted to leverage it and help provide a solution. This gap perpetuates digital inequalities and creates barriers for millions of users, undermining the goal of inclusivity. So, yes, the target audience for our model essentially were the developers, and the affected audience, especially abled people. So, yeah, any developer would now be able to easily bring in considerations for specially abled people. Uh, So yeah, the primary objective of this research is to leverage LLM capabilities to create comprehensive developer-friendly tool for enhancing web accessibility. The following goals include adhering to the standards, simplified development workflow, promoting inclusivity, and empowering developers. This ensures that we have enhanced developer efficiency in also reducing the time taken to them usually to adhere to the standards. This is the architecture diagram on how it would look for anyone else once they want to make websites using a model. So they would have a front end interface. Uh, it would come through an input URL or content to a backend server where we and the blue line, this is where we start the process. Any text stream is put into our LLM model. It analyzes, identifies the issues, post processing module where we fine tune the response, we give proper code outputs, and generates suggestion and formats to the result. Now, this can be used for their data storage, pre processing modules, APIs, monitoring, and logging. Now, this is the entire architecture diagram, and we wanted to focus on this niche part, this blue line, LLM model and post processing module, because these in it come to a very bigger challenge while designing them. Uh, okay, so this is our flow diagram. So yes, once we have found out the scope of our project, we have defined the objectives. We wanted to gather data. We wanted to define the ETL and how we'll be gathering the data. The data also needs to be valid. The open source data we will have available on GitHub, not all of it would be useful, as even I myself have made projects that have almost no code or very minimum code of not that good quality. So data gathering, we wanted to ensure a certain checks. We then pre-process those data. I'll be explaining this step in ahead also in the slides. Once we have the clean and the pre-processed data, we select the LLM framework base model basically, and then we choose the parameters of training this particular model. This is still not over, the tool development. We still uh, want to use more better GGUF models to provide better timing, because the models can go as big as 20-25 GBs. So yes, this is the flow of methodology where I'll be talking about these steps: data gathering and pre-processing data. We wanted to form the data set first. So how did we do that? We referred to open source projects on GitHub. We have to check the licenses. So that was included in the part of dataset cleaning and pre-processing, where we ensure that the project has valid licenses. The project has a minimum of X stars. We assumed X to be 10. More the stars, it is better because it's a renowned open source repo when it has more stars. Uh, Once we have the code now, we are splitting the tag and filtering. Essentially, we are taking out the HTML and CSS of the sites. We are splitting it tag wise, and then we are filtering some of the tags out, like script tags, which would essentially are not useful to us. We are validating the language. We are bringing it down to one language, English, so our model can perform better. And then we are removing some of the redundancies in the code, uh, basically more precising it towards the yeah, basically improving the code before we provide it to our model for fine tuning. uh Yes, this is the data processing pipeline that we had set up: scraping from GitHub repositories, filtering based on languages, HTML and CSS, filtering GitHub repositories based on more than 10 stars, deduplication of code. We are ensuring that we are not providing the same code again and again to the model. We want to ensure good results. We are checking the
Sorry
licenses.
to interrupt you, but you have 1 minute to conclude your presentation.
Sure. Okay. We are filtering out personal information, and then we are providing the accessibility rating. These are some of the WCAG guidelines, error codes. Those are found in the code. These guideline error codes can be found on the WCAG website. We then went ahead with model quantization. The base model that we had trained was close to 14 GB. Precision impact was high, inference speed was high, but we quantized it to 8-bit integer, 4-bit integer, medium sized, 4-bit small, and 2. These models, if you can see, the sizes are smaller. Relative size reduction was very good. Their speed, if I include them in my code IDs like VS Code, they would be extremely fast. But then there would be some precision impact with the other models apart from the baseline model. We then evaluated our model against Code Llama, against Blue, Rauj1, Raujel scores, and we also wanted to compare the time of the prompt when we give it a prompt and how fast it can respond. These are precision scores, and almost everywhere our fine-tuned model performed like Code Llama or better. And we are graphically representing those score comparisons. We also compared our paper with other papers. Not exactly compare, but we wanted to study the existing researches that were done, and then based on that, we had created our model. So yes, we ensured inclusivity. That was our major outcome here. Yeah, that is it. Thank you.
Thank you so much for your presentation. I guess ma'am has dropped some, questions for you in the comments. Either you can reply to it in the comments itself.
So what is the future work? We wanted to ensure that that we can have more code in it as GitHub repositories keep on increasing daily. We wanted to ensure ETL pipelines are set up for every day. More filtering out on the code part. That is one of the major future works. Why did we choose LLM? We did compare the trade-offs between LLM and RAGs. We considered machine learning as a part of it, where let's say some part of the code that we had trained our machine on, and now we no longer need that. We can do that easily with LLMs. And we also wanted the base model to work as it is and uh, improve the base model more on our fine tuning.
Okay. Thank
That
you
is
so
why we
much.
chose LLMs.
Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Aravinda Roshan B to present the paper title, A Survey Writing Image in Dyslexia Research in Education Using Artificial Intelligence Techniques. Are you there, Roshan?
Yeah, ma'am.
Yeah.
Yeah, ma'am. Yeah.
Yeah, you may please continue with your presentation.
A visible screen, ma'am.
Yeah, it is visible.
Good morning, everybody. My research paper is Survey and Handwriting Image in Dyslexia Research and Education System using AI and ML. Yes, my abstract is a work addressing dyslexia, identified dyslexia in the reduced time and whether is a dyslexia and non-dyslexia. Dyslexia is nothing but this is the handwriting inconsistent word, and non-dyslexia is clear and the word consistent word. And proposed I will integrate the CCN and the SVM algorithms for these two algorithms and take the datasets from the Gaggle dataset. CCN is used for the future extraction, that is for the structure of words and space alignment, and SVM purposes is used for consider the dyslexia and non-dyslexia, and this is a uses of two AI and ML AI techniques like grand weight attribution mapping and additive explanation along with the tutoring modules. This is nothing but this is explained as CCN visual decision processing, focus on the area, letter reverse and the non-even spacing, and this is a SAP additive explanation. This is explained a numerical and the future level decision classifier. This is a focus the area of the spacing inconsistent and stroke in annotating flow of handwriting for baseline deviation. It is introduction and dyslexia is basically is a psychology disorder. This is affected 5 to 10% of global population. This can be slow and resolved impractical of this world. This early research basically based on a text. It can be handwriting, that is dyslexia was non-dyslexia, and framework is still reduced lacking. The paper introduced dyslexia detection, that is the created a classroom friendly in personal learning. This is background of paper is that is basically I will told basically is a psychology disorder and language processing. It can be dyslexia disorder is nothing but this is handwriting and reading, listening, writing, that is a skill for the neurogenetic disorder for dyslexia. It can be solved a AI solution, that is SPM and CCN. It can be solved as a solution. Problem statement is a dyslexia detection is the manual assessment for inconsistent for low scale screening, and current AI approach does not integrate with the multiple learning indicator, handwriting and eyes tracking, leading to now less reliable detection. Most SC system lack preventing the educator and understand why the model makes the particular decision, reducing trust in this world. This is the methodology about this is psychology disorder of dyslexia, reading, writing, and this is combined behavior assessment, CCN and LSTM modular to evaluate read, write, listen for dyslexia, and data processing. This is capture data behavior. This is captured for the process to the trained model and activated model into the handwriting, CCN dyslexia. And pattern, this is pattern recognition model. Precision is nothing but this is input processing model with quantum based on the server support segmentation. And this which is explanation CCN and CCN. This is CCN and an explanation. And this is explainable AI techniques, that is a grand explain the CCN visual decision processing, focus on the area, letter is reversible, uneven spacing. This is SAP it can be nothing but it is explained a numerical and future level decision classifier that is including the space inconsistent and baseline deviation. Sorry, 1 minute. Okay. This is a framework, upcoming framework of learning ability analysis. This is a dyslexia order. Reading, writing is listening. This is system integrated behavior data, activate a model and the participant profile, and expert trainers feedback to continuous analysis of behavior and reading, writing, listening. This is the assessment of dyslexia. This architecture delivers the personal feedback and the learning support, dynamic refining each learner skill through expert guidance, and intelligence model is improving the learning outcome. This I told that this combined behavior data set and activated model, and for reading, writing and listening the ability data. There was a dyslexia disorder, a training and expert for the dynamic feedback and continuously refining the learning, so that this LSTM and such a GPT and behavior generated level appreciate reading the material and adjust and nowadays that adjust the teaching strategy in real time is creativity full adaptive and relative learning experience. This is output. This is output, and this is dyslexia was non-dyslexia. Dyslexia is something, it is an inconsistent word. This is an inconsistent word. Handwriting flow is an inconsistent word, and non-dyslexia is a flow. Handwriting of flow of writing is a clear word and consistent data set. And conclusion is true. I propose the dyslexia detection tool, AI based handwriting analysis. AI techniques I use, abstract I told grand CM and SAP to privacy, fidelity learning and classroom development under each. Now future work it can be a data set privacy, that is age variety sample integrated like speech and eye tracking, the handwriting is not clear work. So LSCM to costly to learning the model to deliver the personal evidence and based intervention. This is a reference of the dyslexia, ma'am.
Thank you so much for your presentation. Okay, there is a question for you. That is, what is the use of Z XAI tool? What is the use of XAI tool?
Sorry, ma'am. 1 second, ma'am. Question.
The question is, what is the use of XAI tool and what are the real-time applications?
Ma'am, you say SCR tool is nothing. It's AI techniques. AI technique is considerable the space inconsistent world and baseline deviation of mathematical. It can be solved algorithm for SVM. That will solve a real-time problem, ma'am.
And what are the real-time applications?
It can be considered like the data set. It can be upcoming is a product education dyslexia for handwriting, right, ma'am? Handwriting flow. Then only develop an education.
Thank you so much for your presentation. We'll be moving on to the next presentation now. Next, we have Praveen to present the paper titled Engi Path, a personalized learning and career companion. Are you there, Praveen?
Yes, ma'am, I am here.
Can you please start sharing
Share
your
my
screen?
screen. Okay, I will share my screen.
Okay.
Yeah, you can share your screen. Yeah, I can see your screen, Praveen. You may please start with the presentation.
Okay, ma'am. So, good morning. I am Praveen from Maharaja Institute of Technology. So, our paper entitled is Personalized Learning and Career Companion. So, our co-authors are Ranjit KL, Aditya Murari, and Dilip Kumar HS, and Mone KP. So, next moving to the abstract of our paper. So, it's an AI-driven platform which includes the AI models for the engineering to enhance their career. It contains integrated solutions like career path generator, resume analysis, interview practice, aptitude training, and it's scalable because it includes the LLM models and serverless architecture for reducing the complexity of the project. So it proven effectiveness because we have tried this web app in our college. So around 30 students are participated in the web app, and they have given the effective feedback. So we have analyzed the main major problem is a disconnected path to the career success. Like the majority of the existing tools like Coursera and resume building portals, they will just give a general and isolated solutions to the users. So they lack of intelligent feedback. Like they didn't give any suggestions to the resume. They just give a general template, and it will replace your content with the existing template, and it will give the job ready people less. So in our India, around 15 lakh students will graduate every year in engineering field, but in those people, around only 45% are job ready. So the remaining 55% are not job ready. So to bridge the gap between the academia and industry, we have built the project called NGPath, which improves the problems like personalization. It will give the personalization suggestion for the learning and fragmented tools like resume building, interview preparation, and professional networking and mentorship also. So next, moving to the objectives of our paper, it's a personalized AI career roadmap that will generate the step-by-step career roadmap to the users. ATS friendly resume building, and another one is interview practice, where a model will give set of questions, and the users have to select a role and answer the questions. That model will take the video and audio input and analyze it and give the suggestion and overall resume score, like where you are lagging, and in which behavior or anything you have to improve, you can improve using the AI tools. And a seamless mentorship and networking, you can connect with the people who are present in that web app, and integrated learning and placement preparation in that project collaboration, and like networking with the other people will happen. So next, moving to the literature survey. So we have reviewed and around 20 papers from the year 2022 to 2025, which are published under the IEEE. From that, we have analyzed like AI adaptive learning, which improves the student outcomes, and resume analyzer, like basic resume building tools will give just a template and replace the content. So our resume builder will what do, it will analyze your resume profile and give the exact resume template for which you are applying, like company specific or role specific. So mock interviews, like as I told, it will give you a set of questions and you have to answer. And mentorship program which will be implemented in a college, or also it will be mentorship under the industrial experts. So we have analyzed the single, there is no single system that will offer this much of features. So we are going to build that system with the integrated end-to-end career support. So next, moving to the architecture of our project. So for the front end, I have used Next.js, React, and Tailwind CSS for the modern and responsive UI. So for the backend, we have used Firebase Cloud Functions for the effective and cost-effective operations. So for the AI and implementations, we have used Jenkins tool with Google Gemini. And for the database management and secure storage, we have used the Firebase storage. So this is our architecture looks like. So the here is an user interface. It will connect to the API gateway. It will, if any user asks for the course recommender or teaching model or resume building, it will fetch the data from the database and analyze it with the AI models and give output to the users. So these are the core models of our project. So first one is a career path predictor, which will give the career path for the students. Like it will give ask some set of psychometric analysis questions and like skills and another things from which we have filled in the profile creation. So that will analyze and what you are interested in doing. So by taking all the inputs, it will give you a set of duration based career path. From that, it will give also milestones, so you can complete the milestones and keep track of the work career path. So another one is Resume Studio, where you can upload your resume and check the ATS score or improve the ATS. Or if you are applying for any job, it will give you the job description also for the cold mailing to the company. Next one is A Interview Studio. It will give you the set of questions by taking job role as an input. Like you have to answer that questions by clicking on the microphone and camera. It will record the audio and video. It will process it and give the analyzed output to the users, like where you have to improve or where you are lagging. So next one is aptitude. So majority of the engineering students failing in the aptitude test only, which are conducted by the major companies. So that's a little bit hard thing now. So for that, I have built a system where the users can learn from the system and attend the test there only. Next one is AI course recommender. So like Coursera and Udemy offers courses based on their profiles. So we have analyzed the problem that which course to choose or which one is better. So there is no comparison tool as I observed. So I have built the course comparison where you can fill the data of the two courses or as many courses you want. So it will fetch the it will check the database, and if any course is fit for your profile, it will suggest that if you are wish to go with that course, and you can go it. So next one is project collaboration, where like it's work on common similarly. So if you are in that, you have to create a group that will assign a task as a team leader, and the others will do the task, and they move to the to-do list and in progress and done. In that, I have integrated a real-time chat system for the group, and after the completion of the project, it will be submitted and the team leader will review it and give the feedback. Next one is mentorship and networking. In that mentorship, the students can connect to the mentors, like in the college or in the outside the campus, like industrial experts, so they can get assisted by them, and they can enhance their network within the app, so that the others who are working or who are more knowledgeable than them, they can get knowledge from them and be knowledgeable. So next one is job opportunity. Majority of the job portals, like job hunter or job seekers, will post daily jobs, but what your role specific or what your profile will match to the job, they won't suggest you. So I have built a system where jobs will be fetched based on your profile, and you have to just click on a button like apply. It will automatically upload the resume and a cold mail generated description come to the company mail. So next one is TechFit, to get to know about the real-time tech news, what are happening in the industry. So next one is online GD, where I have integrated Jitsi Meet tool, which will give the live video conferencing with the other members existing in the platform. So where you can have the group discussion or one-on-one interactions, and there you can take notes. And I have also implemented the real-time chat system in the networking and mentorship, where mentors and the students will get connected easily. So next one is admin monitoring. It will be present in every web app. So it will control the overall users and overall the features development and usage of the web app. So next, moving to the here, I have explained the overall features, like how they are working. So I will not take too much time. So I will quickly next move to the result section. So this is our user engagement. System usability in our college around 85%. We have used this for 30 members. So in that we have task completion rate and resume studio adoption, and the score is like little much appreciable because compared to the others. So next, move to the AI performance, key performance indicators, like resume analysis accuracy is around 90%. So overall the tools will give around 85 to 90%. So our resume will also give the 90%. So average response time will be 2.9 seconds. The career path generation will take around 6.8 seconds because it has to fetch the data from the profile and also fetch your psychometric analysis answer. So it will be different from every people. So next one is interactiveness is around 2.7
Sorry to
seconds.
interrupt you, but you have 1 minute to conclude your presentation.
Okay, ma'am. So next is our query latency is 700 milliseconds. So user impact is interview confidence will be improved by 86% of the people in our college. So skill gap identification accuracy is 81%. Like around they have much knowledge, but they are not industry ready. So we have to work on that. So next, move to the comparison with the existing systems. Like our system contains the integrated platforms. That way is our accuracy is around 99. So next, move to the conclusion. So the NGPAR delivers an integrated and AI careers ecosystem that bridges the gap between the academic and learning industry. So it will help the engineering students to get a job while focusing on the academics and also industry. So our future work is in advanced AI fusion and explainable AI. If you give any concept to the AI model, that will give the explanations to the users. So next one is moving to the web application from application to the mobile app. So industrial level deployment with the robust analytics is our future announcement. So thank you. If you have any queries, I can ask.
Sure, your presentation, Praveen. There's a question from you from ma'am. That is, can you please
Yes, ma'am.
elaborate AI course recommender with real-time example?
Like ma'am, course, like I will take in two examples, like Coursera and Udemy in the web development course. Like they both offer the web development course around like $45 and $40, and they vary with the content and the cost and time duration. If your profile you are consistent, and the profile will take the input as if you are consistent or good hardworking. Based on that, it will give you the, like, if you are good worker and hard worker, and that if you consistent, it will give the higher duration course for the more knowledge. But if you are like less investor time investor and ready to learn quickly, so it will suggest you the less duration time and cost. Based on the cost, like which are the concept they are covered based on the data sets, it will give you the course which one is suitable for your profile, and that will get ready to your job.
Thank you so much for your presentation. We'll be moving on to the next presentation now.
Thank you, ma'am.
Next, we have Jay Edling to present the paper titled Fast Modular Inversion in GF on FPGA using Optimized Exponentiation. Are you there? Edling, are you there? Okay, I guess we'll move on to the next presentation now. Next, we have Ganesh Babu to present the paper titled Navigating Virtual Finance, a Bibliometric Approach. Ganesh, are you there?
Yes, ma'am.
Yeah, you may please begin with your presentation.
Ma'am, is my screen visible?
Yes, your screen is visible. You may start.
Uh, Firstly, good morning to all my colleague authors and moderators. In this title slide, the title of my research paper is Navigating Virtual Finance: A Bibliometric Approach. This slide introduces the research paper title Navigating Virtual Finance: A Bibliometric Approach. The title itself reflects the core idea of the study. Navigating implies exploring and systematically understanding a complex emerging research area. Virtual finance refers to financial activities occurring in digital and immersive environments such as metaverse, blockchains, platforms, and Web3 systems. And coming to the next slide, rationale of the study. Rationale of the study, the metaverse. This slide explains why this study was undertaken. Means the metaverse is described as a rapidly evolving digital ecosystem that integrates virtual and physical realities. With advancements in technologies like artificial intelligence, AI, and blockchain, the metaverse is becoming more interactive, practical, and commercially viable. It also increases as per the interest from research and industries and policymakers increases, the number of academic publications related to metaverse has grown rapidly. Also, that this fast growth has created fragmentation in research. Therefore, the rationale of this study is systematically analyze and organize existing research, especially focusing on finance-related applications within the metaverse. And coming to the introduction to the metaverse, this metaverse meaning the meaning and origin of the term metaverse explains the word combines meta meaning beyond and universe, indicating a digital world that goes beyond traditional internet experiences. Also, that the concept of metaverse has taken firstly dating back into the 1992 a science fiction novels No Crash. Also, that who can't term into the digital world. The highlights of introduction on technical advancement, economic and sectoral impact, and metaverse in finance. Coming to the technical advancement section. So technologies like augmented AR and virtual reality create immense environments, allowing users to experience digital spaces in a realistic manner. Artificial intelligence enhances personalization, automation, and intelligent decision making, while blockchain ensures transparency, security, and decentralization. These technologies make metaverse functionable and scalable. Coming to the next slide. Economic and sectoral impact, it highlights strong market growth and high project CAGR, indicating the metaverse is expected to become a major contributor to the global digital economy. This slide, as we can show that the statistics are given in the US dollars 10.105.40 billion in 2024 to grow the CAGR from the year 2025 to 2030. Also, that this expansion increases the demand for the financial system that can support transactions, investments, and create value create within the virtual environments. And coming to the main segment, metaverse in finance, financial institutions are experimenting with metaverse-based services such as digital banking, virtual insurance, investment platforms, and digital asset trading. Also, that with this using of technology, metaverse, with this using of metaverse in finance segment, there is a chance to fraud detection and financial data visualization, which can improve monitoring and decision making. Also, that this is it's like very credible to financial sector. And coming to as we can see this slide, literature review, here the references of the authors who have made their research on this metaverse in finance paper. As we can see, first we can see that Catherine S. et al. Miss Catherine S. Author name is Catherine S. And her team in the year 2024 has made the study on this virtual finance, a bibliometric approach. The only research gap here is there is a limited understanding economic and regulatory risk implications based on the digital transaction. Means the research gap here says that means like in the overall the study, what are the distractions? Means what are the litigations we need to study more and more? Means like these are the studies, the research gaps. And coming to the second one, Ramanar and Mandal S. In the year 2025, they have, as you can see, the title of them is Transforming Business Management, a Machine Learning Approach. Through using the machine learning technology, they have made this research paper, and like that, there are more and more of the literature reviews. And the second paper on the second slide also, you can see most of the others are giving many of this. It's like they made research on this paper. And coming to the next slide, research gap. Coming to this guide, research gap, although interest in the metaverse is rising, research gap states that the only gap, whenever a study has been researched, the only gaps and the litigations we need to study overall in this paper. Although we can say coming to this paper, the general metaverse which is showing is growing rapidly. Study says that scientifically to connect the metaverse with finance and economics is still limited and underdeveloped. Means like the study in this paper, the researchers on this paper is still underdeveloped. Most of the others are from the year 2024 are still approaching to each other to study more and more of this paper. Although additionally there is a lack of detailed bibliometric studies that systematically analyze this intersection. This gap highlights the needs to present study, which aims to organize evaluating existing research in a structured manner. And coming to the objective of the study, bibliometric analysis. The study aims to conduct a bibliometric analysis to assess the current state of the literature on metaverse applications in finance. To get more and more of the applications in the future on metaverse sector in the sector, or on the basis of finance, the study can be the objective. This objective point can be more and more useful. It also seeks to map to research trends, identify influential studies, and highlights gaps that can guide future research. Also, it can be useful for the future research gaps, and also it defines the scope and direction of the study. And coming to the research questions, these questions explain choose and research methodology. Um, the questions focus on identifying recent developments, understanding how research teams are structured, and exploring for future research directions. These research questions provide clarity and ensure that the analysis remains focused and systematic. The main point I kept this research question is it can be more and more useful for the future references, for the future authors who are going to maintain, means make research on this paper. And coming to the next slide, methodology. This is the main segment of this research paper. This methodology is completely based on bibliometric analysis. It is a quantitative approach used to study patterns in different academic publications. Instead of analyzing content subjectively, means like instead of analyzing this whole content in a significant manner, we can use this method focus on measurable indicators such as publication count, citations, and the keyword relationships. I mean, like the number of members are using the total number of members visiting this paper. This make the methodology completely discriminates overall the authors. Means like how many members are going to research this paper, what is the use of this, like this. This makes it suitable for analyzing emerging research fields like virtual finance. In the field of virtual finance, this methodology is the main plays a main and key and important role. Also, this methodology is very useful for data collection. Keywords such as metaverse, Web3, finance, and accounting were applied along with the filters for subject area, language, and publication year. Also, they need to mention their publication year when they are using these softwares like Metaverse, Web3, Finance, and Accounting. This ensures that the only relevant and recent studies are included in this methodology sector. And coming to the final sample of this overall paper, there are total of 84 research articles were selected. Final data set. This careful screening improves the reliability and validity of study findings. A total of 84 study research papers and articles have been selected for this. Means like overall from the out of many of the papers, 84 research papers have been very much used. Coming to the tools used here is VOS Viewer. VOS Viewer, this software used to bibliographic mapping. Means like it helps to visualize a relation between among the other journals and the keywords. Means what are the main keyword, what is the impact word, the terminology they have been used in this paper to the public. By converting complex data into visual maps, this tool makes it easier to identify research clusters and trends. Also, this is a software which ensures the authors to maintain a relationship with its keywords and its keywords, like that. Coming to the next slide, coming to the results. A total of 84, as I said, 84 research papers have been finally analyzed, and also that in the year 2021, there is recent research publications on this navigating virtual finance on bibliometric approach have been increased rapidly after 2021, and also in the year 2024 has been recorded as the highest number of publications. Means like in the year 2024, more than hundreds of papers have been researched in the year 2024, and 2022 papers have received the highest citations. Which like the authors who have made this research have taken these papers for research. Other authors have been taken for these influences. For the references, the annual growth of rate of publications is around 32%, showing how fast development of this field. The virtual finance is a field shows that the annual growth rate of this sector is around 32%, which is very weird and which is very vivid and very fast. Which like come as I don't take much of the time. Blockchain and Web3 dominate current studies. Blockchain and Web3 dominate current studies. Although the paper have been studied thoroughly by the authors and others, this blockchain and Web3 have been the current dominant current studies. Means like most of the authors have been irrelevantly not studying these papers. And next, coming to the next slide, these are the type of references I have given. These references list the academic sources used in the study. It ensures the transparency, credibility, and proper academic grounding. Means like what are the key main roles of key main authors who have researched this paper, and the links have been given over here. Means like overall, these are the references, and this is the end of my presentation. Thank you. If you have any questions, please free to ask.
For your presentation, there is a question for you. That is how this application will be useful for the society.
This application can be useful in the society. The application of metaverse in finance benefits society by promoting inclusion, transparency, innovation, education, and sustainable economic development, while opening new opportunities for individuals, businesses, and policymakers. The metaverse removes geographical boundaries. It's like it does not make complete boundaries, allowing global collaborations like that.
Next question is, please elaborate the blockchain working.
Blockchain working itself states that is the means like it is a how to tell, this is the technology used to study in this paper. Means like in virtual finance, blockchain used to maintain the code relevancy. Means like for the others, it is used for code relevancy. It is used for distributed digital ledger technology to record transactions, to record transactions, and to study more and more of the computer nodes. Once the data is recorded, it cannot be deleted in this blockchain software. With this, the need of the intermediate service banks are will be increased.
Thank you so much for your presentation. We'll be moving
Thank
on
you.
to the next presentation now. Next, we have Adeline Vidya to present the paper title Fast Modular Inversion in GF on FBGA using optimized exponentiation. Are you there now, Vidya?
Yes, ma'am. Am I audible?
Yeah, you're audible now.
Am I? Okay.
You may please start with your presentation.
My screen is visible, ma'am.
Yeah, just waiting for, yeah, it is visible. You
So,
may start.
yes. Slideshow. Okay. So my paper ID is 1403. So my topic is fast modular inversion of GF2 power M on FPGA using optimized exponentiation. So myself, Adnan Vidya, and my co-authors are Dr. Vengadasubramanian, Dr. Rajaram, Dr. Vinod Tyagarajan, and we are from Tyagaraja College of Engineering. So these are my contents. So the contents are as follows: start with the introduction, a literature survey, and followed by objective, methodology, key finding, an analysis and discussion, followed by the proposed architecture, and we concluded the work with by future scope and followed by references. So when talking about the introduction, the spread of internet and communication increases the necessity of security in application, which involve exchange and secret of information. So in this, public key cryptography is widely used for secure communication channel. It requires computationally intensive arithmetic operation with large operand size. So in this cryptographic technique based on ECC, that is elliptic curve cryptography, has revolutionized public key cryptography because of its relatively short operand length. Therefore, ECC is now adopted in many security standards in IEEE and finished ISO for the application, which is key exchange and authentication. So, also several other standards, including this standards, adopted standards for ECC. The high implementation of ECCP on FPGA platform is still a challenging task, and the bottleneck in ECC-based cryptographic scheme is often for elliptical scalar multiplication. So while talking about the hierarchy of this elliptic curve operation, it performs in a top layer model that is influenced by the bottom layer. There is a need for the implementation of a finite field operations. So, while talking about the finite field inversion, because of fast arithmetic over GF2 power n is essential for secure communication. So, in the main bottleneck of the key operation includes addition, multiplication, and especially inversion. Among these, field inversion is most critical and computationally intensive. So, efficient inversion is vital for performance and cryptographic computation. So, this inversion can be done in either two forms. One is Itosuji inversion by two algorithm, Itosuji algorithm, or else extended equilibrium algorithm. So in our work, we preferred Itosuji inversion algorithm. So while talking about the finite field inversion overview, as I previously said, in the elliptical processor, the bottom of it is a bottom up approach only we call them. In this inversion is a critical and computational intensity in elliptical process. It requires compact and efficient computation in order to attain high speed architecture. There are a lot of variants are there in inversion algorithm, that is square alpha, quad alpha, parallel square alpha, and etc. So in our work, we incorporate H eta and quad eta in our architecture. So our main contribution is to use a hybrid-based pre-computed block using H exponentiation. So while talking about ethos inversion algorithm, it developed based on Fermat-Lippi theorem. It efficiently computes the inversion of GF to power n, ideal for normal daily application. So this is the Fermat-Lippi theorem. This is the inversion process done using Fermat-Lippi theorem, and it converts the inversion into a sequence of squaring and multiplication. By converting like this, it can used as a parallel hardware due to its predictable structure. It is preferred over equilibrium method because of its lower complexity and higher performance. So, when going through the literature survey about the inversion, so the first paper they talk about the accelerating Itosuji multiplication inversion algorithm for FPGA. They proposed eta based on a normal quadita. They incorporated in the trinomial field as 193 as well as 33. Whereas in the second paper, they incorporate the enhanced quad. They use pre-computed, without pre-computed, it eliminates the post-computation and improve the inversion operation in the second paper. Whereas in the third paper, they incorporate the head in their work. Whereas in the fourth paper, there is improved optics.
Excuse me, ma'am, are you moving the slides?
Yes, ma'am.
Because I cannot see your slide moving.
Wait a minute, ma'am.
Yeah, now it's moving. Yeah, now it's moving. You may please continue.
Okay. Whereas in the fourth paper they use octet eta, and in the last paper they use as they use as a pre-computation block using 4 power n units. But in our work we incorporated using hex units as a pre-computed blocks in order to improve the high speed image. So our main objective is use high speed ethos-G algorithm development by using 16 power n units. So our main goal is to minimize the clock cycles and enhance the speed as well as optimize the resource utilization and improve the efficiency-based system performance. So our research methodology includes our main computation method. We use the 16 power n block as a pre-computed block for a faster computation. By means of using the pre-computed block, we achieved a high performance in our steps. By this, the inversion steps get reduced within a 24 clock cycles. So the expression details are as follows. In this, by computing these, we are incorporating this pre-computed block in the 233 trinomial. So in this 233 trinomial, we incorporate that is 16 power 29, 16 power 14, 16 power 7, 16 power 3, 16 power 1 as a pre-computed block in our book. So it stores the pre-computation register and the bit are reduced. So by means of incorporating this pre-computation block, the inversion step is achieved earlier as well as the performance increase. And also we are optimizing the hardware implementation also. So this is the key findings. There is algorithm that we have used for the 16 power n algorithm. So in this, the inversion steps is reduced in a 24 clock cycles by incorporating the computed block. and this is our improved control table. So, so from this, we can conclude that the inversion steps it done within a 24 clock cycles, so that we can improve the performance of our architecture. So this is the architecture for GF to power 33 we designed. So as I previously said, we are using the square, square, and we 16 power 1, 3, 7, 14, 29 as a pre-computed blocks we are doing. So by means of this, in between operations get reduced and the speed of the processor also get increased by means of incorporating this multiplication block. So, this is our that is analysis and discussion. So we compare with the previous work, our proposed work, performance get increased. So we incorporated this work in Vertex 4, Vertex 5, and Vertex 7 devices. So by comparing with the previous work, our performance in Vertex 4 is about 87.6. In Vertex 5 is about 345.8, and Vertex 7 is 339.2. So by this, it included by incorporating the pre-computed block, our performance it increases. So our implication and future work is, so our field extension, we are incorporating this pre-computed block in the 233 field now. So in future, we are going to incorporate this in the higher trinomial field as the whole layer, and also we are focused on pentanomial fields also. So by integrating the full cryptographic processor, a complete easily pairing based scheme can be done, and it explore the dynamic reconfiguration to adapt the inversion block. By means of this, the side channel resistance and power side channel attack can be reduced, and the mesh and evaluate its performance on Western FPGA platform also can be done. So, as implementation possibility also, we are in focus for the future. So by this, we concluded that we developed an optimized system power and block for reduced clock cycles, and the reduced latency also get reduced, and it eliminates the redundant block in between, so that hardware complexity gets reduced. By means of this, our performance get reduced due to the reduced clock cycles that we achieved in this computation. By means of this, we get high efficiency and enhanced FPGA process can be designed. So it is mainly applied in the cryptographic requiring for fast evolution. So these are the references we go through. Thank you. Any queries?
Thank you so much for your presentation. The question for you is, what are the real-time applications?
So it is mainly used for this. There is security purpose, security purpose and digital signatures, and for the enhanced security features. That is server and application we are using.
Okay, thank you so much for your presentation. We'll be moving on to the next presentation. Next, we have R. Pavitra to present the paper titled Quantum Enhanced Artificial Intelligence Framework for Early Diagnosis of Autism Spectrum Disorder. Are you there?
Hello.
Yeah, Pavitra, are you
Yes,
there?
ma'am. Can you hear me?
Yeah, I can hear you. You may please start with the presentation.
Yes, ma'am. Please give me a minute. I'll just share.
Sure. You may please start now.
Yes, ma'am. Can you?
Yeah, I can see. I can see your screen.
Yes. Good morning, one and all. Okay. My research topic is quantum enhanced artificial intelligence framework for yearly diagnosis of autism spectrum disorder. Before getting into, like, I wanted to carry on with the session by talking about phrase by phrase. The first phrase is that autism spectrum disorder, because like without understanding what is autism spectrum disorder, we cannot be able to get the gist of the quantum machine learning role in bringing out the early diagnosis. So what is quantum machine learning? What is autism spectrum disorder? Is that it's a neurodevelopmental condition which is meant to affect the individuals. Like it will affect the individuals right from like very earlier stages, like from 18 months onwards. Like once if it is meant to developed in I mean it is a malfunction, like if that condition seems to be affected a individual, like it will be a lifelong condition. It's like we cannot completely come out, we can bring out the person from that spectrum, but by conditioned development or conditioned management methodologies, like some therapies, and then some counterfacts, like we can bring the effect of that autism within the individual in a controlled manner. So once if a child is meant to be affected, like the prolonged barriers will be is that the so-called child will be having difficulty in interacting with the social interacting socially, like there will be found some repetitive behaviors, and then their cognitive skills will be put on under question mark. So this is about autism spectrum disorder. So symptoms, like which seems to be emerging from 1.5 years, but right now, like the diagnosis are meant to be effective only from the age of 3 years of age. The delayed diagnosis, like after the so-called 3 years, will be hindering in bringing out the capabilities of the children until they are 3. So this favored the motivation for my research proposal. So early identification is very critical and crucial for timely therapy or behavioral therapies given for the autistic children. The current clinical screening methods, like are subjective, are meant to be subjective in the sense, like so far, like the children's under 3 years age, or their main problem is that they will be lacking communication skills. That for making the children taken directly for diagnosis process. So obviously the survey kind of things, and then the behavioral behavioral context, all will be gathered from the parents. And then where comes the real question mark is that if a parent being a first time parent, they will not be knowing like what part or what exact behavior will be contributing the child into the autistic spectrum. So again, these kind of biomarkers cannot be actually directly taken for concluding whether the children falls under the artistic spectrum or not. So again, like you need a specific tool kind of thing, like which needs to give the affirmations really at the earliest possible. So so I wanted to take the data set not only from the behavioral therapies or surveys. So I wanted to make it as a multimodal data fusion. So the multimodal will be like from the fMRI, MRI scans, and then EEG signals. So which is as of now like done at a very done at various levels, but using normal machine learning models and then the deep learning models. So these models again lack the scalability and then the high computational efficiency required for handling data like image or audio set and video set gathered on the children's behavior. So there comes the fusion of quantum machine learning and with the classical model. So these are the literature summary of my work. The existing studies shows improved accuracy, but still like they lack the multimodal fusion. Why the multimodal fusion requires is that like data taken at individual level still thrives to gives the exact feature or exact number to classify whether the children will fall under the ASD or not. So they again if some data like video set and EEG signal set, like they seems to be very small data set. So taking that data set for bringing out the feature seems to be like overfitting, and then the annotation errors are there. So it lacks earlier detection capability and provides limited interpretability. Actually, also like the impact of ASD children are that the inferences drawn is diverse, in the sense the each affected individuals will not be showing the same kind of symptoms. They might be having a communication skill problem, and then they will be having a repetitive behavior. They can be having a various socio discrepancies, so in which concluding the symptoms will be varied. So we cannot have a single biomarker. So also the clinical physicians struggle to identify the heterogeneous factor at the earliest possible. So these are the consolidated literature gaps that's been found out from the references. So the traditional ML fails to capture nonlinear high dimensional patterns. Then deep learning models lack clinical interpretability. Multimodal fusion remains technically challenging. The generalization against being a small data set across various populations and institutions. And then the absence of personalized ASD diagnosis models. So the research, so concluding from the research gaps identified, these are my research objectives: to develop a QML algorithms, which main objective is to tailor-made the algorithms taken from the classical and then the quantum enhanced algorithms, and then to make the data itself as a multimodal data, the fusionated data, then enhance the diagnostic accuracy, then validate my clinical applicability to bring out the biomarkers, and then to make it easy go predictive mechanism. So the motivation for my research topic is that the derivation of quantum machine learning. The quantum machine learning is a field, it's a transformation field, which have taken the goodness from the machine learning and then the quantum mechanics, and then it has leveraged the quantum machine learning, has leveraged the goodness of quantum mechanics with the classical machine learning models. The key pillar concepts of quantum mechanics are the parallel processing, and then the quantum entanglement, and then the superposition, making it super compatible to deal with the high dimensional medical data, combining the explainable AI to overcome the current limitations. So this is how the quantum machine learning can map the identified research gap. The classical ML struggles with the high dimensional sorry for the inconveniences. The identified research gap, the classical ML struggles with high dimensional ASD data. So how come this is achieved using quantum machine learning is that using VQZs and using variational quantum circuits, and then the inefficient multimodal fusion will be possible by using the quantum entanglement, forming the quantum states, and then the quantum basis for the Hilbert space, and then the poor generalization across data sets will be mapped by using quantum kernel methods.
Sorry to interrupt you, but you have 1 minute to conclude your presentation.
Okay, this is how the mapping of the quantum based solution can be done on the identified research gap. So let me take to the architecture. So this is the architecture diagram of my proposed work. So taking the behavioral data, MRI data all together can be referred as a multimodal data, from which the earlier feature extraction can be done using the convolution layers, and then using a deep learning layers. From that, where the exact features will be then given to the quantum layer. The quantum layer now will be using some variational circuits, and then the classifiers on the quantum model will be able to diagnose between the ASD and non-ASD features, then which will be taken for the clinical interpretability. So the conclusion falls like this: like this work is a hybrid model which has taken the goodness of quantum machine learning to deal with multimodal data, and then using the explainable AI, it can take the diagnosis possible, and then the interpretation for the differently affected individuals, and to foster a personalized diagnosis methods. Q sharp and then sharp techniques of technologies have been used. Thank you, ma'am.
Much for your presentation. The questions for you are how overfooting problem is resolved.
Okay, by using augmentation methods, and then the attention mechanism of quantum mechanisms, we can ensure that like overfitting can be avoided.
Okay. How you validate the system with the help of statistical approach.
How will you validate? Sorry, ma'am, I didn't get your question.
How you validate the system with the help of statistical approach.
How will you validate?
It's okay. It's okay. Fine.
Okay.
Okay. So we'll be moving on to the next presentation now. Next, we have Beri Usha Nandini to present the paper titled Real-Time Learning Analytics Dashboard Using AI to Monitor and Enhance Student Programs. Usha, are you there?
Yes, ma'am. 1 minute, ma'am. I can share my PPT.
Yeah, you can share your screen now. Usha, are you able to share the screen? Okay, we'll wait for 2 minutes. Are you able to share the screen? Okay, we'll wait for another minute if Usha joins in. Otherwise, we'll move on to the next presentation. So I guess she might be experiencing some kind of failure or problem. So till the time she joins, we'll be moving on to the next presentation. Usha, are you able to join? Okay, I guess she's coming and leaving. So we'll just start with the next presentation till then. Next, we have Khushi Dharmik to present the paper titled Reinforcement Learning for Adaptive E-Learning Systems. Khushi, are you there? Khushi, if you're there, you're not audible. We cannot hear you. Khushi, Usha, anybody of you can hear me, or you can, just share your screen.
Ma'am, can I share my screen, Usha?
Yeah, you can share your screen now, Usha, if you can.
Okay.
Please. And Khushi, you're not audible, so please be prepared. Next is your presentation. Usha, please share.
Ma'am, I cannot share. I mean, this was not supporting to share the PPT, ma'am.
Oh, wait. Yeah, Usha, now you please try to share. Are you able to share it now?
No, ma'am, I cannot able to share. I can
Can
try with
any of your
another.
co-authors share that?
There is no co-author, ma'am.
Okay.
My faculty is my co-author.
Okay, so kindly try to join from some other device. Till then, Khushi, are you able to use your mic now?
Hello,
Yeah,
am I
you
audible?
are audible. Yeah, you're audible now. Can you please share your screen and begin your presentation?
Is the screen visible?
Yes, it is visible. You may start.
Okay. Good morning, everyone. I'm Khushi Dharmik from MTech from KJ Somaiya Institute of Technology, Mumbai. And I will be presenting my work on reinforcement learning for adaptive e-learning systems, focusing on personalization, fairness, and explainability under the guidance of Dr. Vijaya Pinjarkar. So this is the agenda. Moving on. Traditional e-learning systems treat learners uniformly, ignoring individual differences and the way they grasp the topic and how they learn. Adaptive learning aims to personalize this content by responding to learners' progress, engagement, and prior knowledge. And reinforcement learning naturally provides a way to model this process as a sequential decision-making problem where each pedagogical action influences future learner states and outcomes. So this is the literature survey. Early adaptive systems majorly used rule-based tutoring, which lacked flexibility. Classical machine learning models improved the prediction, but failed in modeling long-term learning sequences. Recent RL-based approaches apply Q-learning and deep RL for hint generation and sequencing. However, most systems rely on handcrafted rewards, limited datasets, and rarely address fairness and transparency. Despite these advances, existing systems still suffer from static reward design and limited personalization. There is no fairness and embedded into RL-based tutoring systems. Pre-2015 used static advising and ontologies and used supervised learning for the prediction. From 2015 to 2020, they used RL baselines and Q learning. And from 2020 to 25, they use KT enhanced reinforcement learning, HRL, and knowledge graphs for modeling the sequential process of learning. So these are the major references that I have referred, and these were the limitations observed. The objectives of my system, sorry. So existing systems rely on static content. Reward functions were static and handcrafted. Many studies rely on synthetic and small scale data sets. There was no fairness and transparency mechanisms and rarely embedded in RL driven tutoring framework. These gaps indicate that we need a dynamic, fairness aware, and explainable framework that is capable of generating personalized learning paths using real world data. Major challenges observed are scalability, data sparsity, and reproducibility. Moreover, many of the systems used synthetic data sets that were simulated and are not real world based. So the problem statement is traditional systems nowadays used fixed reward function and model their path that fails to capture the diverse needs of learning styles. So these systems also lack fairness and fail to provide proper personalized recommendation. Therefore, there is a need for RL-based framework that personalizes content while ensuring fairness, transparency, and scalability across diversity of learner groups. The main objectives are to develop a RL-based framework that performs content sequencing for each student by modeling the system as Markov decision process, implement multiple RL algorithms, and conduct a comparative analysis of multiple RL algorithms and compare their results. So these were the data sets used. The main data set is EdNet data set, which has 784,309 students, 131 million interaction, and which is mainly selected for scalability and diversity and provide a real world aspect to the system. Further, assessment will be used for adaptive learning and knowledge tracing research. And Juni Academy is optional dataset, which will be used for comparative benchmarking and cross-domain adaptability. So this is the proposed methodology. The system will be modeled as Markov decision process. There will be state representations which represent the learner states like their current mastery, engagement rate, and concept dependencies. The action space will contain the next actions like selecting next topic, adjust the difficulty level, or provide hints. The reward function, we will use inverse RL to compute the reward function. And the two algorithms used are DQN, which learns discrete action values, and PPU, which ensures stable and efficient training. The system components include learner interface, backend RL engine, teacher dashboard, and admin module. So the training will be carried out in in two phases, that is offline and online deployment. Offline training will take EdNet data sets logs and convert into state, action, reward, and next state tuples. The model will be trained on DQN and PPO agents and use stable baselines for the training. Then we will validate by simulation and cumulative reward. In online deployment, real-time input will be processed to state, ensemble RL engine, selects the next action, and reward will be computed and logged for future training. So this is the system architecture. The proposed system consists of two major phases, that is offline training phase and online training phase, which is connected by a shared hybrid RL engine, which contains DQN and PPO agents, and the architecture integrates real-time learning, adaptive decision making, and explainability tools to personalize learning journey. So in offline phase, we use historical learner logs, which are used to train the RL agents. Then the learner interactions are converted into a state action reward tuple. Then the state builder module generates vector representations of state, capturing knowledge mastery, engagement, hint usage, time efficiency, and difficulty profile. Then the hybrid engine uses DQN and PPO agents. DQN is used to learn value-based decision, and PPO is used to learn statistical policies. Then the model is finally trained, and then this trained model is then transferred to online learning phase. Then the real-time learner activity is processed and encoded. State vectors are computed, and then hybrid ensemble module calculates the hybrid policy using a proper formula. Then the reward engine computes the reward using inverse reinforcement learning. Then the after the reward is generated, actions are provided, and then the after the actions are provided, the DQN and PPO agents updates itself, and then personalized learning outputs are again populated to teacher and admin interfaces, including the learner interfaces also. So the learning path is generated. First of all, dynamic sequencing. The RL agent selects the next action. For example, question, hint, and revision based on learner's current state, which is the mastery, time, and engagement. Then, if the learner is struggling or shows declining performance, the system may reduce the difficulty or trigger revision based on their performance. Then the it also combines deterministic value-driven actions from DQN and behavior-sensitive policy actions from PPO. Then the learner responses are evaluated and scored via a component reward function based on correctness, engagement, and mastery change, feeding back into the agent and updating the agents for further future decisions. Uh, Learners showing idle patterns or off-task behavior are detected, triggering re-engagement strategies or pacing adjustments. So this is the core RL engine. The core RL engine is modeled as Markov decision process containing state, actions, reward, and discount factor. The state will consist of the learner's current state, knowledge, based on their knowledge, engagement, and the hint usage. The action will contain next action state that should be provided. That is, recommend a question, provide hint, suggest revision, or change the difficulty. The reward ensures accuracy, mastery gain, time, and engagement, and the discount factor performs balance between long-term and short-term gain. The hybrid policy fusion after after the training is like after the Markov decision process, the system trains itself on two models, that is DQN and PPO. And then after the output is generated, they use a policy fusion, and then next action is selected. After next action is selected, the user again performs the action, and then reward is calculated. After the reward calculation, the RL agent updates its agents accordingly. So, explainability is ensured by SHAP, which provides a feature attribution to explain whether the why the certain action was chosen. Explanations are visible for both teachers and learners via dashboards. Fairness is integrated via FairLearn to access the correctness and disparities across demographics, and provides equitable content delivery across learner groups. So the expected outcomes are the RL-based model is expected to generate a personalized learning path that dynamically outperforms static rule-based system in adaptive systems. The proposed work is anticipated to achieve enhanced learning outcomes and sustain engagement through iterative reward optimization, incorporating inverse reinforcement learning concepts
Sorry
in
to
this.
disrupt you, but you have 1 minute to conclude your presentation.
Okay. By incorporating inverse reinforcement learning, we ensure the rewards are not static. Integration of explainable AI provides interpretability for instructions and learners. And PPO is expected to outperform DQN in training and stability. So, based on prior work, the model is expected to generalize across domains and various contents. So the proposed contributions are RL framework integrates IRL, comparative evaluation of DQN and PPO, use of large-scale real-world data sets, fairness-aware and explainable personalization. To conclude, major research gaps identified were existing systems relied on static rule-based personalization. Fairness and explainability were absent in many of the systems. They also lacked real-world validation across large-scale data sets. Reward functions were not aligned with learner diversity and equity. The future work will include large-scale deployment in institutional settings and for longitudinal evaluation. The study will bridge these gaps by developing an explainable and scalable RL-based adaptive e-learning framework using PPO and DQN. So these were the references that I've referred. That's all. Thank you.
Thank you so much for your presentation. The question is, can you elaborate the reinforcement learning process in your application?
The reinforcement learning is basically used to dynamically to address how the learners dynamically adjust and how they have various learning patterns. So in reinforcement learning, it will be modeled as Markov decision process, which gives state, action, and reward tuples of each learner. Currently, the state will decide what is the current state of the learner, like what prior knowledge they have, how much time they take to address one question, and if they use hint or not. Then they will answer the question. According to the correctness of the question, the next action will be decided to provide the next question, recommend another video, or recommend some courses, or suggest some hint, or increase the difficulty of the question. Further,
Thank you.
the reward will be taken, and then the action will be provided to the learner.
Okay, thank you so much for your answer. Next, we have Beri Usha Nandini to present the paper. Ma'am, are you there now? Yeah, I can see your screen, but I cannot hear you.
Yes, ma'am. Good
Yeah, I
morning.
can hear you now. You may please start with the presentation.
Okay, ma'am. Good morning, all. My name is B. Usha Nandani. Today, my topic is real-time learning analytic dashboard using AI in monitoring and enhancing student progress. Here, introduction is about nowadays in every colleges or institutions, they are using the online attendance and all the online activities. So in that, I am using the real dashboard for attendance scores and participating data. So it calculates the attendance and also courses all the activities, what are the doing of students. And then the problem statement, as I have identified the problem, is if the number of students data have been stored, the data will be fluctuate, or it may delays in the feedback or late identification of the weak student. And then challenges, research objectives are identifying how common current monitoring problems are across subjects, analyzing users corners about primary accuracy and transparencies. And then these are the literature views about the paper applications, and then their focused areas, key finding contributions, and also research, current researches. I have taken 11 research papers from these years. These are the methodology diagram. First, I have to collect the data. In the data, I have to collect all the different sources like attendance, result, test results, and performances in other activities. And then I have data processing. I have done the data processing layer, like that, cleaning all the courses. I mean, cleaning the test results and then courses, organized and data collections. And I am using the AI analysis for identifying by using machine learning to study the students' data, and then virtualizations to analyze the attendance report in the graphical manner. And then this I have done the survey. So this the participations are 113, and I have using the tools like uh, Google Sheets, Excel, Google Forms, and these are the data collectors like changing in monitoring, most valuable matrices, future preferences, update futures, and AI corners. These are the questions I have been done in my survey. There are 11 questions. These are the questions I have done in my survey. And the results is in the challenging in student progress report. In this, there is a lot of lacking of real-time insights by doing the surveys with my friends and then faculties. All have done this survey. And then data types. In this data type, the higher percentage have been occurred for test and assessment courses. And then dashboard futures. In this, the highest rate is real-time performance alike. Here, update future frequency preferences have done in the real time. The highest percentage also for the real time. This is the radial plot visualizations. I have done the radial plot visualizations based on the current methods of student, I mean challenges in the current methods of student monitoring. In this, the lack of real time insight is the problem, which received 31% of the responses, and then the other feedbacks having 80%, and the problem of poor early identifying of struggling student is at 12%. This all indicates the big problems that this research is trying to solve. Present systems do not provide timely and useful information for proactivity intervention. Conclusion. The research highlights that users, studies, students, teachers, and administrators strongly prefers frequencies such as real-time alert participation monitoring and personalized recommendations. This preference reforms the importance of creating dashboards that are not only technologically advised, but also user-centered and transparent in their data participating, ensuring privacy, clarity in algorithms, behavior, and ethical handling of data are essential for building trust and long-term adoption. Overall, this study contributes to the design of better educational technologies by empathizing explainable AI, role-based access, and actionability analysis. These are the reference I have been used for this paper. Thank, thank you.
Thank you so much for your presentation. There is another question for you, that how reinforcement works in your work. Nanya, are you there?
Yes, ma'am. Ma'am, just I have done the survey based on the papers, but I did not go deep in that, ma'am.
Okay, okay. Thank you so much for your presentation. So I sincerely want to thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of ICTCS 2025. Before ending this session, I would also like to take a moment to thank our session chair, Dr. Archana Preetham, for chairing this session. Ma'am, this is a token of appreciation to the chair on the behalf of the whole team of Global Knowledge Research Foundations and Partners and ICTCS 2025. Thank you so much for your valuable presence. Before ending the session, I kindly request everyone to kindly turn on their cameras for a quick snapshot. Thank you so much, everyone. Stay safe. Take care.